How's it going, Venus?
Good.
Good. Where is the rest of our class today?
I don't know. It's 2:25.
I know. All right. Well, just you and me. So go on and get started on your do now. And hopefully the rest of them will join us. All right. One more minute to think about question number 2 and 3. All right, make sure to turn on your video. I can't be the only one showing my beautiful face. Great, we see Venus. All right, let's go ahead and get started. How do you add and subtract fractions? How do you add and subtract fractions? What do you have for me, Hannah?
You find the common denominator and then subtract it like you would do any other number.
Cool, good job. How do you divide fractions? How do you divide fractions? What do you have for me, Venus? I think you're still muted.
Hold on, let me get back to my notes. How you divide? I don't got it on here.
Oh my goodness, you guys, I'm so sorry. I didn't realize class just started right now. That makes no sense. I was like, why is it just one person? Okay, let's restart. Do the 3 minutes over again. This always happens. Sorry about that. Mermaid Man and Barnacle Boy is a good one, Ethan. All right, 20 more seconds, 20 more seconds. All right, let's do this again. Hannah, could you repeat your answer for number 2? How do you add and subtract fractions?
You add and subtract fractions by finding the common denominator and then subtracting as you regularly subtract.
Good. And then Venus, how do you divide fractions?
Don't you keep change flip?
And what does that mean?
I don't know. I don't got it down on my paper.
If you have 2 fractions, you keep the first fraction, you change.
Yeah, then you change the sign, and then you flip the second fraction.
Yes, good job. All right, let's go ahead and do our good things for today. So today's good things are coming from, let's see who we got today. Let's do Hannah, Liana, and Nancy.
My good thing is that this Saturday is like our family fish fry. So like all my family from Cincinnati and Richmond are coming, and then I got a birthday party I'm going to this weekend. So it's gonna be lit.
Yep. I got a packed weekend. Nice. Liana, what's your good thing?
Well, my new phone case should be coming in today or tomorrow. So.
Oh, what's your phone case? What's it gonna be?
It's just like it's just clear.
Cool. So. Awesome. Thanks for sharing. And then Nancy, what's your good thing?
I ate pizza today for lunch.
You know I love pizza. What kind of pizza did you eat?
Just regular pepperoni with sausage.
All right, solid. Thanks for sharing. My good thing is that I have a book club meeting today, and I actually finished the book in time. Woohoo! And this is our first in-person meeting since COVID, so I'm excited to see my friends and discuss some books. It'll be fun. All right, announcements for today. Midterm grades are going in today at 3:15. So if you have any issues with your grades, make sure you check on Skyward, make sure everything looks good. If you do not let me know by 3:15 that something is wrong, then that's what's getting sent out. So make sure that you check them, send me an email if something looks wrong. Next, are there any questions from last night's homework? Okie dokie, then let's get this party started with today's stuff, which is Intro to Rational Expressions. So it's a little bit of bringing together what we talked about last week with radicals, as well as some of the stuff we've been talking about with fractions. So a rational exponent is basically an exponent that's a fraction. So anytime you see an exponent that's a fraction, it's a rational exponent. And it's just another way of writing out a radical. So instead of using radical form, you can express that same idea using a rational exponent. Expressions with rational exponents can be rewritten as radicals using the following rules. So you can go between both forms. That's the whole point of it. The first type you might see is an exponent where you have 1 in the numerator over n, which could be any number. So it's a to the 1 over n. And the way that we would say that is the nth root of a. So if I wanted to change this to a radical, the base a goes underneath the radical. The denominator of your fraction is your index. So that goes inside the little crevice of your radical. And those are the same thing. Saying a to the 1 over n is the same as taking the nth root of a. So those are the same exact thing. We're used to seeing this, but now we're going to convert to rational exponents. What if you have a number other than 1 in the numerator? That's what we call our m. So you could also have a to the m over n, and we call that the nth root of a raised to the mth power. Same idea. Your base goes underneath the radicand, so it's a underneath. N is your index, and then m is your exponent. Questions so far? All right, so the first examples, we're gonna convert between radical to exponential form. So we're starting with radical form and we're going to exponential form. So the first thing you wanna do is identify your m and identify your n. Your n is always the index. So in this case, the index is 3, so n is 3. And then your m is always the exponent. If you don't see an exponent, your m is 1. So 16, there is no exponent for it. So the m is 1. All right. You keep the base, so whatever is underneath the radical. So in this case, it's 16. And then you raise it to the power of m over n. So that's your fraction. M goes on the top, so 1 over 3. So it's 16 to the 1/3. 16 to the 1/3. All right, let's look at number 11. We've got x, y. So we got to find our m and we got to find our n. Our m, I don't see an exponent, so I know my m is 1. And my index is the number that would be right here. If I don't see a number, I know that the index is 2. So it's the same rules as last week. If you don't see a number in the crevice, you know that the index is 2. All right, this time we have 2 different variables, x and y. So you want to make sure you put them in parentheses so that the exponent goes to both the x and the y. If you didn't put the parentheses, then that would just mean that the y gets the exponent, which is not what you want. So it's m over n, so 1 over 2. 1 over 2. All right, now I'm gonna ask you all to help me out. So for number 12, we've got the 4th root of 8w. So we gotta find the m and we gotta find the n. So what's my m, what's my n? What's my m, what's my n? What do you have for me, Sandra?
Your m is 1 and your n is 4.
Good job. You have a number and a variable underneath the radical, so make sure you put them in parentheses. So 8w in parentheses, and then m over n, 1 over 4. All right, number 13, we've got cubed root of 11 squared. What's my m? What's my n? What's my m? What's my n? What do you have for me, Liana?
The m is 3.
Other way.
2.
Because m is the exponent, so what would n be, Liana?
The n will be 3.
N is the index. So what would my final expression be? What would my final expression be? What do you have for me, Ethan?
It would be 11 squared in parentheses and then 2 over 3
So you actually don't have to put
as
parentheses
an
around it
exponent.
because it's just 11. It's not like 11 and a variable. So if it's just a coefficient, you're fine. And then it's 2 over 3, yes, as your exponent. Good. All right, number 14, 4th root of k to the 5th. What's your m? What's your n? What's your m? What's your n? What do you have for me, Karen? Karen, you
I
there?
started talking to myself. I forgot. 4.
4 is,
The M.
sorry, I couldn't hear you one more time.
The M.
The M is 4, you said?
Oh wait, no, opposite. 5 is M, and then the N is 4, right?
Yep. All right, so what would my expression be? What do you have for me, Venus?
Would it be K and then 5/4?
Yep, absolutely. Good job. All right, last one, 15. Square root of 3m raised to the 7. So what's my m and what's my n? What's my m, what's my n? What do you have for me, Nancy?
Your N is 2, and then your M is 7. No, yeah, 7.
Yeah, it's a little different because it's all raised to the power of 7, but it's the same thing as if it was. Yep, good job. So you take the 3m, since it's a coefficient and a variable, put it in parentheses, and then it's m over n, so 7/2. Questions on changing from radical to exponent? All right, now we're gonna go the other way. So they're gonna give us an exponential form and we have to switch it back to a radical, and we have the extra step of evaluating it. So we have to figure out if we can simplify it if possible. So let's look at number 1, 16 to the 3/2. So same idea, identify your m and your n. When you're looking at your fraction, the number in the denominator is your n, so your n is 2, and the number in the numerator is your m. So when I rewrite this, I'm going to draw the radical, the base, so 16 goes underneath the radical. 3 is the exponent, so it's 16 to the 3rd. And then 2 is your index, but you don't have to write an index of 2, so you can just leave it as the square root. All right, couple things we could do here. We could find out what 16 cubed is and then do your factored tree, but that's actually a lot of work and it's kind of annoying. So what I would suggest is go ahead and break this up into 3 16s multiplied together. So 16 times 16 times 16. And then because your index is 2, you're going to circle groups of 2. So you have a pair of 16s over here. So that means you can take out a 16, you're left with a 16 underneath the radical. So that already simplifies it a little bit because now you got as much as you could out of the radical and you're just left with the 16 inside of the radical. So now I just have to simplify 16. So if I do a factor tree, I'm going to find 2 numbers that multiply to give me 16. Do 4 and 4. Which breaks up into 2 times 2 and 2 times 2. So I'm going to rewrite this as 16 square root of 2 times 2 times 2 times 2. And we're circling pairs, so I can take out a 2 from here, a 2 from here, and then nothing is left uncircled, so the radical disappears. 16 times 2 is 32. 32 times 2 is 64. Some of you might have been able to notice a shortcut. So if you look up here, the square root of 16, that's a perfect square. The square root of 16 is 4. So you could have just stopped over here and done 16 times 4, and you would have also gotten 64. It's up to you. The only thing I would say is that the longer version of factoring out works for any index. So it'll always work. So it's good to be in that habit because this method doesn't always work. But if you want to save some time, then you could do it this way as well. Questions? All right, let's look at number 2, 4 to the 5/2. Let's find our m and let's find our n. What's my m? What's my n? What do you have for me, Hannah?
Your M is 5, your N is 2.
Good job.
So I'm going to rewrite this. So put the base 4 underneath the radical. The exponent is 5, so it's 4 to the 5th, and then I don't need to write the index because it's just 2. Again, you could do 4 to the 5th and figure out what that is, but simplify what you can. So I'm going to rewrite this as 4 times 4 times 4 times 4 times 4. So 5 4s. And your n is 2, so we're circling pairs. So you can take out 2 4s, and you're left with this uncircled 4 right here. All right, we need to, that's a lot easier to simplify than this. So we're going to just simplify the 4, which simplifies to 2 times 2. And we're going to circle pairs. So we have a pair of 2s. That's 4 times 4. Take out a 2. There's nothing left uncircled, so the radical disappears. So it's 4 times 4, which is 16. 16 times 2 is 32. And you could have taken the shortcut over here. 4 times 4, the square root of 4 is 2. So that's also an option. Questions on number 2? All right, let's look at number 3, 32 to the negative 3 over 5. Remember that we cannot have negative exponents. So I'll take a volunteer for this question. How do we deal with negative exponents? You can go ahead and unmute yourself. How do we deal with negative exponents? How do we get rid of negative exponents? Any volunteers? You just say your guess. Doesn't have to be right. We'll work through it together.
Oh, do you find the square root?
No, not exactly. Remember, we pretend that this is a fraction, so we can make this a fraction by putting it over 1, and then you flip it. So the 1 goes on the top, 32 goes to the bottom, the negative changes to a positive. Does that ring a bell, everyone? That's how you deal with negative exponents. You have to flip. So if this is in the numerator, it flips to the denominator, vice versa. If you have a negative in the denominator, it flips to the numerator. And then the negative exponent changes to a positive number. All right, still got to find your m and your n. So what's my m? What's my n? What do you have for me, Ethan?
The m would be 3 and the n would be 5.
Good job. So I'm going to rewrite this. So it's 1 over 32 goes in the radical. The exponent is 3, so 32 to the third, and then 5 is your index. So I'm going to try to simplify this. So I'm going to try to rewrite the 32. So it's 32 times 32 times 32. Unfortunately, I have an index of 5, so I need to circle groups of 5. And I don't have enough 32. So in this case, if you can't simplify it like this, then you have to go and just break apart one of the numbers. So just break off one of the 32s. 32 breaks off into 2 times 16. 2 is a prime number. 16 breaks up into 4 times 4. 4 breaks up into 2 times 2. 4 breaks up into 2 times 2. So this is going to be 1 over the 5th root of, you've got 5 2's, so 2 times 2 times 2 times 2 times 2. Another 5 2's, so 2 times 2 times 2 times 2 times 2. And then your last 5 2's, 2 times 2 times 2 times 2 times 2. Questions so far? All right, the index is 5, so we're circling groups of 5. So I can take out a 2 from each of those groups, so it's 2 times 2 times 2, and that's 1 over 8. 2 times 2 times 2 is 8. Any questions on that one? All right, last one, number 4. We've got 9 to the negative 1/2. So same thing, we've got a negative exponent. How do I get rid of the negative exponent? How do I get rid of the negative exponent? What do you have for me, Karen?
I don't know.
What did we do over here when we had the negative exponent?
We canceled it out.
Well, I had 32 to the negative 3 over 5, and then it became 1 over 32 to the positive 3 over 5.
We switched it to the denominator.
Yes, you got to flip it, and then what happens to the exponent?
It becomes positive.
Yes, and math always sounds better in British. Yes, great.
Yes.
So you got to flip it. So it was in the numerator, so now it goes to the denominator. The negative 1/2 changes to a positive 1/2, like platform 9 3/4. Also, side note, I just found out that all the Harry Potter movies are taken off of HBO, and I never got a chance to do a Harry Potter movie marathon, and I'm really bummed about it. It's fine. I'll be okay. I'll get over this, but I just thought that you all should know that. Anyways, let's find our M and our N. Okay, what's my M? What's my N? What do you have for me, Liana?
Okay, so the M is 2.
Switch it. So the denominator is always your N, the numerator is always your M.
So 9.5.
I mean, you just look at the 1/2, right? The denominator is 2, so that's your index, and the numerator is 1, so that's your M. Does that make sense, Liana?
Yeah, I mean, I keep getting them mixed up.
Yeah, I think you keep switching them. So just remember, denominator is the N, numerator is the M. All right, from here, we're going to rewrite this as a radical. So it's going to be 9 underneath the radical. The M is 1, so I don't have to write that exponent, and the index is 2, so I don't have to write that either. 9 breaks up into 3 times 3, so it's 1 over the square root of 3 times 3. The index is 2, so we're circling pairs. So we can take out a 3. So it's 1 over 3, the radical disappears. You could have also noticed that the square root of 9 right here, that's a perfect square. The square root of 9 is 3, so you could have taken the shortcut and gotten to your answer as well. Any questions about number 9? All righty then. Does anyone still need this before I switch the screen? Okay, so let's go ahead and go over your homework for tonight. Two things, you've got your Big Ideas Math 5.1 assignment. That's new. That's going to be due on Wednesday. And then you have your fractions operations worksheet from last night. That's on Canvas. That will be due on Tuesday. All right. You are welcome to stick around and get started on your homework with me. I'll stay until 3:15. If not, have a wonderful day, and I will see you tomorrow.